Today we're going to talk about simplifying rational expressions using multiplication. To simplify rational expressions, first we're going to factor the numerator, aka the top, and the denominator, aka the bottom, if possible. So you have to remember your factoring rules. The first rule of factoring is factor out the GCF. Second rule of factoring is count the terms. If it's one term, it's a monomial. If it's two terms, it's a binomial. If it's three terms, it's a trinomial. And usually after three, we say it's a polynomial, even though technically two and above is a polynomial. Then if it's a binomial, ask yourself, is it a difference of squares or a sum or difference of cubes? And if so, use the appropriate formula for that scenario. If it's a trinomial, that is a quadratic in standard form, you're going to use the guess and check method, the X method, slide and divide, or split the middle with the box method. If it's a polynomial of degree 3 or higher, you can use synthetic division to help you factor it. Otherwise, you could use grouping or the box method. So again, factor the numerator and denominator if possible. Number two, once you've factored, you want to cancel out the common factors from the numerator and the denominator. So the common factors have to be on top and bottom of each other. It doesn't have to be directly on top and bottom, but one has to be on the top, one has to be on the bottom. Perform the provided operation, either multiplication or division, with the remaining factors. And today we're just going to multiply. And lastly, write your final solution in its simplest form. So these are the steps we're about to take in the next examples. Let's begin. So for example 1, we have some basic fractions that you should be familiar with from middle school. So to simplify this expression, I highly suggest you simplify before you multiply. So that's why I wrote out the steps that I did in the manner that I did on the previous slide. So the first thing we're going to do is look for common factors. So we're going to factor every term, the terms in the numerator and the terms in the denominator, and look for common factors. So the factors of 6 we know are 2 times 3. You could also use 6 and 1, but let's go with 2 times 3 for now. The factors of 25 are 5 and 5. The factors of 10 are 2 with 5. And the factors of 4 are 2 with 2. Again, there's other possibilities, but let's just start with these for now. So when I look at the top-bottom relationships, I notice that there's a common factor of 2. So on the second term, the 10 over the 4 part, there's a 2 times 5 over a 2 times 2. So I can cancel out the common factor of 2 from both of those terms at the top and the bottom. Now, I recognize that I have a factor of 5 at the top of the second and a factor of 5 at the bottom of the first. As long as one is on top and one is on bottom, you can cancel them out. So I can cancel out this 5 and one of these 5s. Notice you can only cancel 1 for 1. So same thing with this 2 at the top left and that extra 2 at the bottom right. Those 2 will cancel each other out. So boom, boom. And if there are no more common factors, multiply the remaining factors. So this is technically 1 over 1 now. So it'd be 3 times 1, which is 3, and 5 times 1, which is 5. So that would be the simplified expression for number 1. number 2, now we started introducing variables, so we have algebraic expressions. So we have to remember our factoring rules that I mentioned before. So first thing we want to look for is factoring out a GCF if possible. So the top left term is a binomial. It's a linear binomial. So since it's linear, most likely there is a GCF. And in this case, there is a GCF of 2. So I'm going to take it outside, parentheses. And when I take the GCF of 2 out, ask yourself, what times 2 gives me 2x? So that would be x. What times 2 gives me 6, or positive 6? I need a positive 3. So again, these were the factoring rules we've talked about in semester 1. And again, we talked about them at the beginning of semester 2 in the third 9 weeks. So you should know these things when you see them quickly by now. But again, if not, please ask questions later. At the bottom left, it's a squared binomial. And I see a perfect square of x squared, and 25 is a perfect square, and there's a minus sign in between. So that means this is a difference of squares. So to factor out a difference of squares, there is a formula that we talked about. The formula being a squared minus b squared is equal to a plus b times a minus b. So that's the formula if you remember it. If not, remember that there's going to be 2 sets of parentheses. You're going to have a plus and a minus, and just square root both terms. So the square root of x is x. I'm sorry, the square root of x squared is x. The square root of 25 is 5. And that's how you apply the formula, essentially. Write down the multiplication bullet that separates the 2 fractions or rational expressions, technical term. At the top right, it says x plus 5, which is linear. But in that particular case, there is no GCF. So let's just rewrite it, x plus 5. At the bottom right, I see another linear, but I do recognize that there is a GCF, which is 6. So 6 times what gives me 6x? X. 6 times what gives me a positive 18? A positive 3. And boom. So we've factored both numerators and denominators to the best of our ability. Now look for common factors and see who will cancel. So when it's algebraic, you can't just take one term or the other. You have to take the whole algebraic expression. So what that means is I see an x plus 3 in parentheses in the top left, but also in the bottom right. So I take the entire expression, the entire x plus 3. I see an x plus 5 in the top right, as well as in the bottom left. So again, I take the whole expression. I can't just take the x or just the 5. I have to take the whole thing. It's all or nothing. Oh, I do recognize that 6 can be factored. So let's rewrite what we have so far, just to clean it up just a tad. So again, this is 1. So that's 2 times 1 at the top, which is 2. At the bottom, it's 6 times x minus 5. Okay? But again, 6 can be factored because we did it on example 1. So with that being said, we already know that the factors of 6 are going to be 2 times 3, right? And we still have x minus 5. And I did that for a reason, because that means I can simplify it even more, because there's another common factor that can be canceled out. This 2. So again, I took away a 2 from the top. There is still a 1 up there. So you always have to have something at the top. You can't leave the top blank. With that being said, there are no more common factors. So at the top, all I have is 1. At the bottom, I would have 3 times x minus 5. And you can leave it in factored form. You don't have to multiply it back together. It's totally fine the way it is. So now, example 3. At the top, again, we see some algebraic expressions. At the top left, it's a trinomial. It's quadratic and a is 1. So we can use the x method for that top. So let me write out my fractions and my bullets so I can already have them in place and save some room for scratch work on the side. So for the top left, I'm going to use the little x method. So again, you put a times c at the top, which is 6. You put b at the bottom, which is 5. And ask yourself, what factors of positive 6 will give me a positive 5? So we know that the factors have to both be positive because a times c is positive and b is positive. So the two factors that multiply to give me 6 and add to give me 5 are both 2 and 3, which means that the factors for x squared plus 5x plus 6 are going to be x plus 2 times x plus 3. Now, for 4x, we know that 4x is equivalent to 2 times 2 times x. So let's write it that way at the bottom. 2 times 2 times x. Now for 12x squared, there are various ways to do this one. I'm going to go as low as possible, which means all prime numbers, and it's totally fine. So that means 2 times 2 is 4, times 3 is 12. And then x squared is times x times x. So I'm going to write all these factors at the top. When you write the factors, you can use bullets or you can use parentheses. So since I've been using parentheses, I'm going to keep that consistent. It's fine either way. And then the remaining denominator, 3x squared plus 7x plus 2, a quadratic trinomial in standard form, but this time a is 3. So that means you use slide and divide or split the middle. I will use split the middle since most of my students enjoy that one better. So again, it starts off with your x. At the top of your x, you're going to put a times c. A times c is 6. At the bottom is b, which is 7. Since a times c is positive and b is positive, again, your factors have to be positive. So the factors of 6 that give me 7, it can't be 2 and 3. We did that before. That's not. It's going to give me 5. So we have to use 1 and 6. Now the purpose of that was to split the middle. In other words, 7x is now becoming 1x and 6x. And then we draw our box, remember? I'm not showing every step that I technically used to take, but you remember the process. You should. So each term goes in a box, so 3x squared, 1x, plus 1x, plus 6x, yes, signs are critical, and plus 2. Now find the GCF from the top row. From the top row, it's x. X is the only thing both terms have in common. So what times x gives me 3x squared? We need a 3x. What times x gives me positive 1x? We need a positive 1. What times 3x gives me 6x? We need a positive 2. And double check, positive 2 plus positive 1 is positive, I'm sorry, positive 2 times positive 1 is positive 2. Yes, it sure is. So that means the factors of the denominator would be 3x plus 1 with x plus 2. And now we cancel out our common factors. So I see 2 times 2 at the bottom left and the top right. I see x at the bottom left and at the top right. And then I see x plus 2 at the top left and at the bottom right. So now multiply what remaining factors we have. So at the top, I have x plus 3 with 3 and x. So 3 times x plus 3. At the bottom, I only have 3x plus 1. So parentheses aren't necessary anymore for that one at the bottom. I'm practically done, but if you want to clean it up just a smidge, you can actually multiply the 3 with the x and get 3x, and that's the only thing you need to multiply at the top. You can leave x plus 3 in parentheses, and you have a perfectly good answer. So that would be the simplified version of that expression. And this concludes your notes for today.